students, welcome back to another lecture in our course Environmental Modeling and Simulation. Today we will continue our discussion on 2D linear systems. I want to use some examples today to help you understand 2D systems better. So let's get started. Now the example I am going to use today is an informal example. So I'm not going to use examples that are relevant for environmental context. But I hope the informality of this example will help you understand this, will help generate more interest in this part of the course. So let's say we have two friends and let's give them a name. Let's call one friend G because the first alphabet of my name is G. And let's say the other friend is F because the first name of one of my dearest friends starts with alphabet F. So let's say we have two friends G and F. And we want to model their relationship, and let's say they're exactly identical people. You know how there is a belief and a very famous saying that goes like birds of feather flock together. So let's say these two girls are birds of the feather, they're flocking together, they're becoming good friends, and they're exactly similar. Their approach towards friendship is also very similar. So we want to model this relationship. And yes, you heard me right. We can use the concepts that we are learning in this course to model friendships, to model relationships between human beings, between animals, between any biological entities, and even the relationship between different compounds. So the concepts, the basic mathematical concepts that we are learning in this course are widely relevant. And here we are talking about two friends, one we are calling person G and the other we are calling person F. So let's say with time, relationships change, people's feelings change, sometimes they move and they go to different universities and then they're not as good friends as before. We are not going to account for all those external factors. We are just going to look at the effect of personality on the kind of relationships children develop between themselves. So let's say the way in which the feelings of G towards F change are governed by AG. So what is the G's feeling currently towards F? Plus BF. How does F respond to G? So basically what you're seeing here is that dg by dt. Now here just to be clear, G is a person, one, a child, and F is person two. Basically they're children in school, right? They're friends. In the equation, however, I'm using G, capital G, same alphabet, capital, to represent the feelings that G has towards F, and the capital letter F to represent the feelings that F has towards G. So here we are talking about person, and here we are talking about feelings. So if in the model G and F are positive, it means they have friendly feelings towards each other. If G becomes negative, it means that G has negative feelings for F, does not like it, wants to become enemies. Okay, so we are going to see how G and F change with time when G and F are two people, two students in a class who are exactly similar to each other. So dg by dt is the rate at which the feelings are changing over time, feelings of G. So here we can see that dg by dt depends upon two things. One is AG and the other is BF. So basically G is a student, a person whose feelings towards their friend F will change according to how they are feeling currently. So let's say G doesn't like F, G is angry at F. Then G is negative and that will impact the direction in which G's feelings go. It will also impact the feelings of G towards F will also be impacted by current feelings of F, which is denoted here by capital F. So let's say if friend thinks that G is a good person and they want to be good friends with G, then F is going to be positive. So this is going to improve the feelings that G has towards F. Okay. So now let's model the feelings of F towards G. Now I told you they're identical people. They are people with similar backgrounds and they're studying in the same school, in the same class. So they have similar taste and dislikes. So obviously the conventional wisdom goes, oh, they'll be good friends. They'll share notes and they'll help each other through preparation for exams and support each other through high and lows of life, school life. So A and B are going to be the same constants that are going to be valid for df by dt. So this will look like this. Now if you are wondering why I have switched the constants, it is for a very obvious reason. A is a constant that is put before how G's current feelings affect the direction in which G's feelings are moving. So this is A is a constant for feelings of the self, and B is a constant for feelings of the other, who is a friend in this case, friend or enemy, whatever. So here the self is F and the other is G. That's why I've switched the constants. Okay. So now we have two equations and we are going to solve them. Now this is a scenario where two birds, we are looking into mathematical representation of the famous saying, birds of feather flock together. I think it's birds of a feather flock together. I'm not an English literature person. I have not majored in English, so I may be wrong here. Alrighty, so what we are going to do is, first step, find the fixed points. So given that A and B are not 0, so we know that A and B are non-zero in case, then we know for sure that the only fixed point for this system is when both G and F are equal to 0, right? This is the only fixed point. So if we are trying to make a phase portrait, put G here, put F here, then the only fixed point is 0, 0. Now we need to understand the stability of this fixed point. So the second step now would be to write the characteristic equation. So if you remember the characteristic equation, we take the constants and we put them here in the same sequence that they occur. Remember, if I had written this equation as AF plus BG, just to confuse you a little bit, please do not make this your characteristic equation. To write your characteristic equation, you have to make sure that you are writing the variables in the same sequence. Alright, so the characteristic equation is this. Now you have two possibilities. You can go ahead and find the eigenvalues, where the traditional approach would be determinant A minus identity matrix lambda is equal to 0, and you find eigenvalues, and which is actually something that we might end up doing eventually. Or you can take the shortcut, which is find the trace, the delta determinant, and tau square minus 4 delta, and then use these values and the chart that we covered in the previous lecture to understand how the fixed point will behave. Is it a stable fixed point, an unstable? Is it saddle? Is it the center of a spiral, a fixed orbit? And what kind of spiral in case it's a spiral? Okay, so let's go ahead and do this. So tau is equal to 2a. Aha! Delta is equal to a square minus b square. And then tau square minus 4 delta is going to be is going to be 4b square, which is always positive. So we know that in the graph that we consulted last lecture, tau and delta are going to be outside the curve. So let's look at the graph. So here is the graph, right? What do we know? Tau square minus 4 delta is greater than 0. So we are not inside this curve. So we are not dealing with a case when we have center or spiral. Tau is equal to 2a and delta is equal to a square minus b square. Alrighty, let's assume that a and b are positive constants, right? Because these two children, these two students are good people at heart. They want to make friends, they don't want to make enemies. So dg by dt is equal to ag plus bf, and df by dt is equal to bg plus af. A and b are both positive, right? If the other person, if f likes g as a person, then g will be like, okay, I can be friends with this person. They're not bad, they're good people. Okay, so notice here that tau is 2a, so this is going to be greater than 0. So when tau is 2a, tau is positive, we are not dealing with fourth. Let me use another color for this. We are not dealing with fourth or with the third quadrant. We are dealing with either the first or the second quadrant. Alrighty, so tau is greater than 0. Now let's look at delta. Is delta positive or negative? So let's say a square minus b square is positive. We are saying delta is positive. If delta is positive, what is the condition required for delta to be positive? The condition required for delta to be positive is that a square is bigger than b square. So let's say now if we look at it in our equation, which is written here in small font, a square being bigger than b square, it means that G and F are kind of people who rely on their feelings more to decide how they are going to respond to a person compared to the feelings of the other person, which is B. A is how my own feelings affect how I think about the other person over time. B is how other person's feelings towards me will affect how I think over them. So in this case, when a square is bigger than b square, we are dealing with a situation where delta is positive. So delta is positive, now we are in the first quadrant. Tau square minus 4 delta is positive, which means we are dealing with unstable node. So now let's look at what happens to their friendship when we have unstable node, 0, 0 is an unstable node. So here let's plot G, here let's plot F. 0, 0 is an unstable node, so it is going to repel. Now what we want to do is we want to find out eigenvectors. So let's go ahead and do that. So let's come back to this. To find eigenvectors, first we need to find eigenvalues. So there's another way of doing this, but let's do it the right way. Let's do it the long way. So this is the characteristic equation, and we end up with so you can solve this equation and you can find out what your eigenvalue is. So we have two eigenvalues here. All right, a plus minus b. So now we can substitute these and find out the eigenvectors. So let's find out the eigenvectors first for a plus b. We're going to get a non-trivial solution. Alrighty, so we got, it's a non-trivial solution, but we know the ratio of V1 and V2. Now let's look at what happens for the second eigenvalue. Lambda 2 is equal to a minus b. So we are going to substitute the lambda 2 value in this. Students, I hope you're not just waiting for me to arrive to the solution, but you're taking time to actually write and solve it at the same time. It is very important in this course that you actually have a notepad with you and you are scribbling as I'm trying to solve this. And then routinely you can check in to see if your answer or your solution matches mine. Again, we are getting a non-trivial solution. V1 by V2 is equal to minus 1 by 1. Alrighty. Now we know the direction in which this particular fixed point is going to be an unstable node. So let's draw the phase portrait. If A square is bigger than B square, since A and B are both positive, that's the assumption we made. If A is bigger than B, 0, 0, the phase portrait looks like this. 0, 0 is an unstable node. Its two eigenvalues are A plus B and A minus B. For A plus B, V1 by V2 is 1, 1. So we take one step forward in direction of G axis, one step in direction of F axis, and this is our eigenvector V1 corresponding to lambda 1. Now for second lambda 2 A minus B, the eigenvector, the ratio of V1 and V2 is minus 1, 1. So we take minus 1 step in G and 1 step in F, and then we link them. This is corresponding to V2 and lambda 2, repelling in both directions. If A and B are both positive, A plus B is going to be bigger than A minus B, correct? Which means lambda 1 is going to be bigger than lambda 2, which means that lambda V1 is going to be the faster eigenvector, V2 is going to be the slower eigenvector. So remember, in case of stable nodes or unstable nodes, your trajectories will become tangential or tend to become tangential to the slower eigenvector. So this is how your flow lines or your trajectories look like. Now we have drawn the phase portrait, yeah? Let's take a moment to understand what does it mean for the two students, F and G, who met in a school and who may or may not become friends. But they're identical people, their response towards people around them is governed by same constants, A and B, A being the constant for how their feelings change, what feelings they have for the other person, and B is about how they reciprocate to the feeling of other people. If they meet, what will happen? Let's say we are starting in the first quadrant. So first quadrant means both F and G are positive, which means both F and G think good about themselves, about each other, that yeah, this person is good, this student is good, and both of them share mutual admiration. In that case, since you're starting in the first quadrant, notice for any starting point in the first quadrant, eventually what's going to happen? F and G are going to increase. So basically their friendship will get deeper. They'll become better friends over time. So even though I have not calculated a quantitative answer to the equation that we wrote down for this friendship, qualitatively I know that if A is bigger than B, and at the beginning when F and G meet, they both think that, oh, this person is a good person, I would like to be friends, share notes with this person, lecture notes. Over time, they'll become really good friends. They might even help each other crack competitive exams and really support each other throughout life. So good friends, right? Now let's see what happens if at the beginning, they start in the second quadrant. Starting in second quadrant means at time t equal to 0, F naught, which is initial feelings of F, are positive. F thinks G is a good person, but G naught is negative. G thinks this person is not good. F is not good. F doesn't like F, maybe thinks this person is too haughty or whatever. Now let's see what happens. In this particular case, notice that depending upon where this initial point is, of course, let's say this initial point is above V2. Yeah, so it is above V2. So it is in this section of our phase portrait. If the starting point is in this highlighted section of our phase portrait, eventually with time, this is what's going to happen. Even though initially F naught was negative, F naught was positive, G naught was negative, G thought F is not a good person, but over time they will start realizing that no, both are good people and they can actually be very good friends. So even though initially the class teacher may be like, oh, G doesn't like F, but over time they'll be like, oh, these two have become really good friends. Now let's see what happens if the initial point is below this vector V2. So I'm going to highlight that place first. Let's use another color. So we are dealing with this situation. They're starting here. So let's say this is the initial point. It is starting in the green highlighted portion of the face portrait. Notice what happens here. Initially, F naught is positive, so F still thinks G is a good person, but G naught is negative, so G thinks, oh, this person is not good. So basically, the dislike that G has for F is bigger than the dislike that F has for G. Sorry, the like that F has for G. So in that case, notice that all the flow lines are moving here. So even though initially F thought that G was a good person, over time what we'll see is that these two people will have very negative feelings for each other, because now we are headed towards a place where both F and G are negative, going to negative infinity. So over time, the longer these students stay in the school, in the same class, they will have more and more misunderstanding, mistrust, and they will really hate each other over time, maybe. Okay, now let's start in third quadrant. I hope this is exciting for you at this stage, because you see, you can model friendships, you can model how two relatives are going to behave with each other, how two politicians who are coming together for doing some good work in the community will interact over time depending upon their personality. Here, F and G are exactly replica of each other. They have exactly the same personality. You can also slightly modify this model to talk about what happens when two opposing personalities meet. Let's say one person is a social worker really trying to do good work, the other person is a businessman, and they team up to do some social entrepreneurship. How is their business relationship going to evolve over time? Are they going to continue working for next 3 decades in the social entrepreneurship? Are they going to split and move out? You can do all those kinds of modeling using this. Okay, now let's come back to this example. Now let's say we are starting in the third quadrant. In third quadrant, it means that both F naught and G naught are negative. So at the beginning, both F and G thought, oh, this person is horrible. Over time, what will happen is that their feelings will get worse and worse towards each other. They're not going to like each other. They're not going to tolerate each other. Now let's come to the fourth quadrant. Much like second quadrant, the fourth quadrant also is the behavior, the eventual fate of the relationship between F and G is going to depend upon where the initial point is located relative to the eigenvector V2. So once again, I'm going to spend some time highlighting the two portions of fourth quadrant, and then we'll look at two different possible starting points. Okay, so let's say we are starting here at the yellow portion. Now in yellow portion, what's happening is that in fourth quadrant in general, what's happening is that F naught is less than 0, G naught is positive. F does not have a good opinion of G. G has a decent good opinion of F. Now in this case, notice in the yellow portion, all the trajectories are moving in this direction, in a direction where eventually what will happen is both F and G will be positive and they'll continue increasing. So if they're starting in the yellow portion, eventually they will be, even initially, even though F did not like G, they will end up becoming good friends and they will really support each other and do good work together. Let's say we are starting in the green. So let's say we are starting somewhere here. All the trajectories here are pointing towards minus infinity for both F and G. So basically, even though initially G thought highly of F, over time they will have negative opinion of each other. Okay, this is when A is greater than B. All right, what happens when A is less than B? Let's take a look at that. So the face portrait we are going to draw when A is less than B. So remember our eigenvalues, A plus, hold on, A plus B and the related vector 1 by 1, and then eigenvalue A minus B and the related vector minus 1 by 1, right? Same thing holds true when A is less than B. However, what is interesting is what happens here. Notice, if A is less than B, delta A, which is A square minus B square, will become negative. So your tau is still positive, but your delta becomes negative. Your tau is still positive, you're still either in first or second quadrant, but now your delta is negative. We are dealing with a saddle point. Anytime your delta is negative, we are dealing with saddle point. So now again, more important to find eigenvectors. Okay. So we know the two eigenvectors corresponding to lambda 1. Since A is less than B, lambda 2 is going to be less than 0, right? And A is less than B. So here we are going to have attraction towards a fixed point. This is in this manifold we are going to have repulsion from the fixed point. So let's say 0, 0 is still our fixed point, but it's no longer an unstable fixed point. When A is less than B, we are dealing with saddle node. Okay. So V1, the first eigenvector corresponding eigenvalue is A plus B, it is positive. So in this direction of eigenvector, the trajectories are going to move away from the fixed point. In the next eigenvector, V2 corresponding to lambda 2 A minus B, since A is less than B, A minus B is going to be negative. The direction of flow is going to be towards the fixed point. This is the saddle case. So if you remember, the trajectories in the saddle case look like this. Now let us see what happens depending upon what's the initial impression that F and G have of each other. So let's say we are starting from the first quadrant. Okay, I'm going to color this entire phase portrait again to divide them into different zones. Okay, so what I have done is I have colored shaded this phase portrait in two different zones. One is a yellow zone and one is a light blue zone. Clearly, I hope it's obvious to you that I have colored these into two different zones depending upon how I know the behavior will be if our starting point is either in the yellow zone or in the light blue zone. So let's start from the yellow zone. In the first quadrant, anywhere where we are starting, in as long as because first quadrant is entirely in the yellow zone, notice all the trajectories are moving towards plus infinity for both F and G, which means if two identical people meet each other and initially they have a decent impression of each other, over time their friendship will get deeper and stronger, right? So here, if F naught and G naught are positive when A is less than B, their admiration and friendship for each other will continue increasing. Let's say we are starting in the second quadrant. Now, if you are starting in the yellow portion, same thing will happen. Their friendship will get deeper. If you are starting in the blue quadrant, over time, what will happen is, even though at beginning, in second quadrant, G naught is negative, F naught is still positive. But over time, they will develop dislike for each other and they will not be able to work together. If you are starting in the fourth quadrant, all the trajectories are pointing towards minus infinity for both F and G, which means if two identical people meet and they don't like each other at the beginning, over time it will just get worse. Let's start in the fourth quadrant. In the fourth quadrant, if you are starting at the yellow place, now in the fourth quadrant, notice G naught is positive. So G has good impression of F and F naught is negative. F does not think highly of G. If you're starting in the yellow portion, eventually their friendship will get deeper and even F will start thinking that G is a good person. But if you're starting in the blue portion, look at the trajectory. The trajectory is going to move towards minus infinity for both. They are going to like each other. So this is a very interesting situation where depending upon the initial point, we know how the behavior is going to change. As long as, to summarize, as long as the starting feelings for F and G, identical people, is above this line, this particular line, they are in the zone where they'll have positive feelings for each other. But if the starting values of F and G are below this line, then F and G are going to tend to minus infinity. So this is known as a Basin boundary because it is separating two different basins. One is going towards plus infinity, the other is going towards minus infinity. Alright students, this is all for today. In the next lecture, we'll continue this exploration of 2D systems and very soon we'll enter 2D nonlinear system, which is where the real environmental magic lies. Thank you.